This lesson is titled Solving Linear Functions. Our objectives are to algebraically solve linear functions and to solve word problems that use linear functions. Linear functions are used to model many types of real-world phenomena. Therefore, learning to solve linear functions will help you find answers to many real-life situations. To begin, let's solve some generic problems before we jump into the applications. So in this first example, we are going to consider a linear function, f of x equal to 5x plus 75, and the question states, when will f of x equal 125? Now we've solved a problem like this in a previous section where we used a graph of a function. Now we want to do this algebraically. Our first step is to take that 125 and substitute it in place of f of x in the function's definition. And that gives us this equation that we see here, and this is something we can now solve. 125 equal to 5x plus 75. Our first step is to subtract the constant from both sides. So the constant cancels on the right-hand side, leaving just the 5x term. And 125 minus 75 leaves us with 50. And now we want to get the x variable isolated, so we divide by its coefficient on both sides, leaving us with 10 is equal to x, or you can switch the order and say x is equal to 10. So here's a second example. Okay, so this should say g of x is equal to 15. We're going to take that 15 and plug it in place of g of x. And we get the equation 15 equals 80 minus x over 2. Or if you prefer, you can say 15 is equal to 80 minus 1/2 x. These are exactly the same. It's two different ways we can write it. X over 2 is the same as 1/2 times x. Seeing it in this second form might make it easier to acknowledge that we need to multiply this by 2 to isolate it in a later step. So to continue, let's subtract 80 so we get it away from the x term, and we'll move it to the other side of the equation. The 80s will cancel on the right-hand side. This leaves us with negative 65 is equal to negative 1/2 x. And now, to undo this 1/2 x, we can multiply by 2. And anything you do to one side of an equation, you must do to both. So 2 times negative 165 is negative 130. And negative 1/2 times 2 is negative 1. And our last step is just to divide both sides by negative 1, because we want to know what positive x is equal to. So we get 130 is equal to x, or you can switch the order and say x is equal to 130. Here in example 3, we are asked to consider a linear function f of x that passes through 2 points, 1, 8 and 3, 4. And using those data points, we are asked when will f of x be equal to 0. So we can use the points to calculate slope and then solve for the b value in the mx plus b equation. Recall that the slope formula is m is equal to y2 minus y1 over x2 minus x1. And we can name this first point x1, y1, and the second point x2, y2. And when we plug it into the formula, that gives us 4 minus 8 over 3 minus 1. 4 minus 8 is negative 4. 3 minus 1 is 2. Negative 4 divided by 2 is negative 2. So we have a slope of negative 2. And now we can take that slope with either one of these points, it doesn't matter which one you choose, and plug it into f of x equals mx plus b, or if you prefer, y equals mx plus b, because we said that y and f of x are interchangeable with one another. And if I take the point 1, 8 I see that x is 1 and y is 8. So I'm going to replace y with 8. I'm going to replace x with 1. And don't forget our slope is negative 2. And after we've plugged all of those values in, we're left with just the one unknown, which is the b value. And we can solve for this. So multiply negative 2 by 1, and we get 8 equals negative 2 plus b. Add 2 to both sides to isolate b. And we see that b is equal to 10. So now that we have the b value and the slope value, we can write the linear function f of x is equal to negative 2x plus 10. And now the final question, when will f of x be equal to 0? So we will replace f of x with the number 0. And now we have an equation that we can solve, just like we did in our previous two examples. And we want to get the x term by itself, so let's move the constant first. Negative 10 is equal to negative 2x. Now to isolate x, divide by its coefficient. Negative 10 divided by negative 2 is a positive 5. So 5 is equal to x, or you can switch the order and say x is equal to 5. So examples 1, 2, and 3 were generic examples, and what that means is there was no word problem attached. We were just going through the mechanics of the mathematics with the linear functions to solve for x, slope, write the equation, things of that sort. Now we can apply this to word problems. So our first word problem says, suppose that a real estate office handles an apartment building with 50 units. When the rent per unit is $580 per month, all 50 units are occupied. However, if the rent is increased to $625 per month, the average number of occupied units drops to 47. So this should make sense. As things get more expensive, less people are interested in purchasing it. So what we have here with this example is just like the last one we finished, example 3 of the generic problems, where we have two sets of points, and from the two sets of points, we write the linear function, and then we can solve some problems with it. So our first point has an input value of 580 and an output value of 50. So if I were to write this as xy equal to 580, comma 50. And then our next point or ordered pair is 625 as the input and 47 as the output. And it says assume that the relationship between rent and demand is linear. So we're going to write a linear function. That means use these 2 points to find slope and your b value. So our slope is 50 minus 47. So if this is y2 and this is y1, 50 minus 47, that means this is x2 and this is x1. We're going to do 580 minus 625 in the denominator. And 50 minus 47 is 3 for the numerator. But for the denominator, we have 580 minus 625. That gives us negative 45. And this reduces to negative 1 over 15. So that's our slope value. Now we need to find the b value. So we can write y is equal to mx plus b. We already know that m is negative 1 over 15. And we just have to choose one of our 2 points to plug into the x and the y variables. So I can plug in 580 for x and 50 for y. And our equation becomes 50 is equal to negative 1 over 15 times 580 plus b. And if we do 580 divided by negative 15, that gives us negative 38.6 repeated. I'm going to use math. Option 1 is frac, and convert that decimal to negative 116 over 3. So 50 is equal to negative 116 over 3 plus b. Now we would like to change this number 50 to be a fraction that has a 3 in the denominator, so we can combine those constants. So 50 over 1, if we multiply top and bottom by 3, gives us 150 over 3, and that's what we want to replace our 50 with down in this equation, because with fractions we need matching denominators to combine those terms together. So now we should be able to see that we're going to add 116 over 3 to both sides. It'll cancel from the right-hand side, and 116 plus 150 will give us 266 in the numerator and 3 in the denominator, and that will be our b value. So slope is m, which is negative 1 over 15, and y-intercept is 266 over 3, and that is the linear function that we have written here. Now that we have the linear function, part B of the question says, use this equation to predict the number of units occupied when the rent is $6.55 per month. Remember, rent is the x variable, which is the input. So if we put $6.55 in for the function, that means we're going to replace the x variable in the equation with $6.55. So negative 1 over 15 times $6.55 plus 266 over 3. So we can get our calculator to enter this. 655 divided by negative 15 gives us negative 43 plus 0.6 repeated. Now we're going to add to that, and whenever you're entering a fraction, use parentheses. 266 divided by 3, so that's our b value. When we hit enter, we get 45 units, and that's what the answer is here. And for part C, it says predict the number of units occupied when the rent is $595 per month. So you're going to plug that in for your x in the function. So you can do this work yourself and see that you will get the answer 49. So part D says to graph the equation and label the axes. So the x-axis was the rent. The y-axis was how many apartments were rented. And we can take some of our ordered pairs. This first point up here was one of the given points that says $580 rent would have 50 units occupied. This next point was another ordered pair we had, which said that if the rent were $625, 47 units would be occupied. And this was one of the problems we solved with our linear function. When we had $655 as the rent, 45 units were occupied. And when we connected these points, we see that they have a linear path. Example 2 is a classic algebra problem. It states that two trains leave a station at the same time traveling in opposite directions. Train A travels west and train B travels east at a rate that is 20 miles per hour faster than train A. So we can say this is train A, and this is train B. For train A, we can say speed equals x. For train B, we can say speed equals x plus 20. The next sentence says, after 3 hours, the two trains are 360 miles apart. So they're both traveling for 3 hours. And the combined distance is 360 miles. So with this problem, we have to use some knowledge that we're expected to know, and that is that distance is equal to rate times time. So we can take this train A and say that train A distance is equal to rate times time would be rate is x, time is 3, so that would be 3x would be the distance that train A traveled. Train B has a distance, the rate is x plus 20, and the time is still 3. Let me fix this 20 down here and multiply it by 3, and we can distribute this 3 through here and say that train B's distance is 3x plus 60. The combined distance is 360 miles, so we should add 3x to 3x plus 60 and set it equal to 360 miles. So we have 3x plus 60 equals 360 miles. So this equation will work, and we can combine the 3x's together. So that gives us 6x plus 60 equals 360 miles. And that's the equation that is up here. So this answer doesn't have it distributed. This answer has it distributed with like terms combined, but they are equivalent. And x represents the speed of train A, as is outlined here in our notes. So now you can solve this equation. Our goal is to get x isolated, so we'll subtract the constant from both sides. 6x is equal to 300. Divide both sides by the coefficient of x. X is equal to 50. If x is equal to 50, then train B is 20 miles per hour faster. So x plus 20 would be 70. And we see that train A is 50 miles per hour, train B is 70 miles per hour. Example 3, a new wireless company offers a cell phone plan that provides unlimited talk and texting for $29.95 per month, but it charges $9.95 for each gigabyte of allocated data. Part A says write a linear function that calculates the monthly bill. Well, every month you're going to start with a $29.95 per month fee, and then every month the amount of data you use will differ, but that will be multiplied by $9.95. This is the starting value. This is the rate of change in the bill. We should think of the starting value as the starting point in our graph, which is the b value, and we should think of the rate of change as the slope, which is the m value. So if I have f of x equals mx plus b, and we've identified that 995 is the slope and 2995 is the y-intercept, then we can write that f of x is 995 times x plus 2995. And that is the equation here, where x represents the amount of data allocated. Part B asks, how much is the cell phone bill if you allocated 5 gigabytes of data for the month? So because the x is the amount of data, and we're talking about 5 gigabytes, we're going to evaluate f of 5, which means 995 times 5 plus 2995. 995 times 5 plus $29.95 gives us $79.70 for the cell phone bill, and that's what we have here. This is the end of the notes for this section. So go back, watch it, pause it as you need to, take notes, move on to the practice section, check your answers with the answer key, and once you feel prepared, move on to take the section quiz. This is the last quiz for this course, so once you've finished quiz 4, you've completed the course.